Recording in progress.
Okay, all the students joined the class already. Does your school counselor tell all the students for 8th grader, 9th grader, you will have the PNCT on October 11th? Okay, suppose they should send out this notice or maybe at the end of the August, okay? Now let's continue with what we learned last week. Last week, we learned many centers. So if we draw the angle bisector, they will meet at one point. This point is called in-center. If you draw a circle with this in-center as a center, and you draw the perpendicular line to each side, okay? By doing triangle congruency, you are able to prove these three pieces all equal because this is angle bisector. These two angles equal. They share the same side reflexive property. At the same time, you also have a 90 degree. You can call this AAS to prove this triangle and this triangle are congruent. Or you can use right triangle congruency theorem. There are 4 theorems for right triangle. You have HA, hypotenuse angle, LA, leg angle, hypotenuse and the leg, and leg and the leg. So this angle and this side, you can choose, say, LA. Okay, oh, sorry, this is H, hypotenuse and angle. So you can prove these two triangles to be congruent. Okay, you can either use AAS or you can use HA to get these two congruent. If these two congruent, then you have CPCTC to prove these two equal, and also this two equal, and also this two equal. This is your radius for this in-center circle, okay? That's for in-center. For the next one, circumcenter, you will draw the perpendicular bisector, which means this point is a midpoint. This point is a midpoint for this side. This guy is a midpoint for this side. And then you will see these 3 lines meet together at one center. This center is called circumcenter. The name is a little bit hard to remember, but look. Same way, doing triangle congruency. This triangle is congruent to this triangle because they share the same side reflexive property. These two pieces equal, definition of midpoint. This angle are both 90 degree. Right angles are congruent. So you can have SAS to prove these two triangle congruent. And then you do CPCTC. Corresponding parts of congruent triangles are congruent. So these two pieces equal. Or you can use those HALA, HL, and LL. For these two right triangles, you have leg equal, another leg equal. So by LL, you can prove these two right triangles are congruent. And then CPCTC tell you these two green lines are equal. Same way, this also equal. this piece equals this piece equals this piece. You can see, treat this guy as a center. Use this guy as a radius. And then you draw a circle. This circle will be able to touch the 3 points, okay? In pre-calculus, right now you're learning geometry. After geometry, you learn algebra 2. After algebra 2, you learn pre-calculus. In that class, you will have a famous law. It's called law of sine. Law of sine. In law of sine, there is a famous formula called sine A over A equals sine B over B equals sine C over C, okay? And this is equals to 1 over 2 times R. This is the capital R, okay? Yeah. You will learn this until pre-calculus 2 years from now. I make this class a little bit advanced because all of you are very good students. Okay. Next, we talk about a centroid. Definition of centroid: midpoint, midpoint, midpoint. You connect this and this and this. So this 3 median will cross at 1 point. This point is called your centroid, okay? Called centroid. There is interesting information here. This piece divided by this piece is 2. This piece divided by this piece is 2. This guy is also double of this guy. To prove those ratios to be 2, we used triangle congruency theorem and triangle similarity theorem by extending the line over here. Makes this 2 equal. And then you draw here. Yes? Because you make this 2 equal, you know this was given equal. So these 2 triangles are congruent. If it is congruent, then this angle here equals this angle here. If you find these 2 angles equal, you can say this line and this line parallel because alternate interior angle theorem inverse, okay? Converse, because these 2 angles equal, so this line parallel to this line. After you prove this line parallel to this line, you will be able to also prove this small triangle and this big triangle are similar by AA, AA, okay, AA. So you can say this guy divided by this guy is 1 over 2. This guy divided by this guy is 1 over 2. Well, interesting thing. That means this piece and this piece equal. You prove this piece and this piece equal. You also know that these 2 parts equal. So you are saying this guy is double of this guy. Okay, that's what we did last class. Okay, this is about centroid. The most important property for centroid is this is double this. This is double this. This guy is double this guy. Okay. The last thing, the last center is called orthocenter. How do we draw the orthocenter? Actually, drawing orthocenter is not hard. You will draw a perpendicular line through the vertices to the opposite side. And you draw this guy perpendicular to this line. Okay, and the same way by drawing here. These 3 perpendicular lines will meet at 1 center. That center is called orthocenter. Okay, orthocenter. Now we finish drawing over here. Can we draw the orthocenter? Let's first draw the acute triangle. For the acute triangle, go ahead, get your ruler and start to draw, okay? This is 90 degrees. There. There, okay? Yeah, this guy is called the orthocenter. For acute triangle, orthocenter is inside the triangle. Next, we want to draw the obtuse. Everybody, please draw on your own paper, okay? Next, we are going to draw the perpendicular line here. Okay. Everybody has to draw it, okay? Okay. So for the obtuse triangle, if you want to draw the altitude, you draw this way. This is easy to draw. But from this point, if you want to draw the altitude, this altitude will be outside the triangle, okay? Because this is bigger than 90 degrees. If you want to draw the line perpendicular to this line, you have to extend this way, and then you draw the perpendicular. Same thing for here. If you want to draw from this vertices perpendicular to this line, you have to extend this triangle this direction, and then you draw it. Well, these three altitudes meet at the same point on this location. Okay? Everybody finish drawing this? Have you finished?
Almost.
Okay.
Can you repeat what you said about drawing it? I'm not exactly sure how to.
Okay. So you first draw the perpendicular line here from this point. Okay. So far, so good.
Yes.
Okay. This altitude is easy to draw because this altitude is inside the triangle. And then you want to draw the altitude through these vertices. You want to draw this guy, but you know, if you draw the perpendicular line, this is bigger than 90 degrees. Your perpendicular line will not fall inside this triangle. It's going to be outside, right? You want to draw the altitude from this point perpendicular to this line. So you have to extend.
Oh, yes.
Okay. And then you draw this point perpendicular to this line. This is 90 degrees. Okay. And you go here. This is the altitude for this obtuse triangle through these vertices. Correct?
Yes.
Last one. You want to through these vertices. You want to start from this point And then you draw the altitude. This guy will not fall in here because this is bigger than 90 degrees. Your altitude will be outside also. So you draw here, correct?
Yes.
Okay. So the 90 degree is here. This is 90 degree. This is 90 degree, and this is 90 degree, right? And then these three altitude meet at the same point, okay? Yeah, this is called the orthocenter for this obtuse triangle. For acute triangle, the orthocenter is inside the triangle. For obtuse triangle, the orthocenter is outside the triangle, okay? So far, so good?
Yes.
Okay. Debbie, do you have any question here?
Can you, is it okay if you say like what is being perpendicular to what?
So to draw the altitude, you have to start from a given vertices. For a triangle, this is one of the vertices. This is the second vertices. This is the third vertices. Does this make sense?
Yes.
From here, you draw perpendicular line, easy. Just go there. From here, how do you draw the perpendicular line to this side? You have to extend this line first, correct? So you draw this way. Make sense?
Oh, okay. Yeah.
Same thing for here. You have to draw the perpendicular line, so you have to extend this line first. Make sense? Okay, there you go. These three lines meet at the same point. Okay. Okay. That's the orthocenter for the obtuse triangle. This is the orthocenter for the acute triangle. Correct? Last one. Let's draw the orthocenter for the right triangle. Okay. Look at this. You want to draw perpendicular to this direction. So you draw the altitude here, and this is 90 degree. And then you will draw from this point, look, this is the vertices. You draw the perpendicular line to the other side. Well, this overlap, that's okay. It could overlap because this is the right triangle, so it will overlap. Make sense? And you draw from this is your vertices. You will draw the perpendicular line to the other side. So this can overlap. So for this right triangle, this altitude and this altitude and this altitude, they three meet at the same point over here. Does this make sense? Everybody okay here?
Yes.
I think so, yeah.
Okay, all right. So that's about all the four centers, okay? That's about all of those four centers. In center, you have a circle which is tangent to the triangle inside. For the second center, you can draw a circle which will have a radius, okay? The center to these 3 points will be equal distance. These three equal, you are able to draw a circle like that. These two difference. This circle is inner, so it's called in center. This circle is outside, and you call it circumcenter. For the centroid is made by drawing the medians through each side. This is called centroid. But you need to know the important properties. this guy is 2/3 of this whole median. The last one is orthocenter. You draw the altitude from each vertices. These 3 points are called the vertices. So you through each vertices, draw the perpendicular lines. And they will meet at the same point. You call this position, this point, orthocenter. Okay. The interesting for orthocenter is it's going to be outside the triangle. For the obtuse triangle, it's going to be exactly on those right angle vertices position when you draw this for a right triangle. Okay. All right. Now, so far, any question? No questions. You notice that geometry becomes more and more complicated. Now, in this class, we will continue with similarities. We learned about triangle similarities, but we haven't learned the similarity inside right triangles. So for geometry, when two different concepts mix together, hard thing comes, okay? When you have right triangle with similarity together, something hard comes. Let's first, I'm going to see here. Please, everybody, draw on your paper with rulers, okay? Do the same way as what I did. Okay, I draw a right triangle, which is saying this angle is 90 degrees. And I draw an altitude here. I call this A and B and C. And I call this point D. Okay, so this is triangle ABC. Now look at here. I start with the smallest triangle, AB. Inside this triangle, which one is the smallest triangle?
The smallest is angle B.
Angle
A triangle.
A. CAD, okay? Look, this guy is the smallest triangle, correct?
Yes.
Okay. So we start from the smallest angle. In this triangle, we have 3. First one, second one, and the third one. And we have 3 triangles inside this graph. And we start with the smallest one. And with the smallest one, we start the rotations this way. This is the smallest angle. This is second one, and this is third one. So I call CAD. Look at this. Similar with in this.
BCD.
Very good. Similar with
BAC.
Very good. BAC. Yeah. Bryson and Debbie, are you both okay for here?
Yes.
Yeah.
Okay. Now, Bryson, we know these triangles are similar, supported by what? What's the reason we can say they are similar? In triangle similarity, we have 3 theorems. What are those theorem names? First is
AA,
good. Second,
SAS,
third,
SSS.
very good. This guy is supported by which one?
Wait.
Look,
Huh?
for this triangle and this triangle, look, we know this guy plus this guy equals to 90 degrees, correct?
Yeah.
And we also know this guy plus this guy also equals 90 degrees, correct?
Yeah.
That's why this guy has to equal this guy, right?
Yeah.
So this is supported by AA, right?
Oh, yeah.
This is supported by AA. Yeah, for this triangle and this triangle, they have both a 90 degree and they have an angle, okay? So it is also AA. Next one, Debbie. We already listed the triangle similarity correctly. Now it is time to write down the proportion. Can you tell me CA over who? Yeah, so we are going to check these 2 triangles by writing down the similarities.
CA over BC.
Okay, hold on. So you have CA over BC equals
AD over AD.
CD, right? CA over BC equals to AD over CD equals
CD over BD.
CD over BD. Okay, all right. Now look at this. In this proportion, do you see something repeat itself? Do you see which one repeat 2 times?
Yes.
CD repeat 2 times. So cross multiplication, CD square equals
ABG squared?
No. CD square equals AD times BD, right?
Oh, yeah.
So CD square is AD times BD. Make sense? This 2, correct? Okay, that's a famous important property. Okay, now Abby, let's do the same proportion for the last 2 triangle. Go ahead, please.
BC over BA.
Okay. BC over BA
equals CD over AC
equals
BD over BC.
okay. All right. Now, do you see some guy repeat itself?
BC.
So
So BC squared equals AB times BD. I mean BA times BD.
that's fine. Now look at here. Debbie gave us this this guy square is AD times BD. AB give us this. BC square equals to AB times BD. Okay. Now, Branson, let's do this triangle with this triangle. Okay.
Okay.
Go ahead.
Wait, which one?
Yeah, the first one and the third one.
Oh, wait. C, wait. Oh, C,
CA.
B, CA, equal, divided by BA,
Yes.
equals AD, divided by AC,
Okay.
equals CD divided by BC.
There you go. Did you see somebody repeat itself?
AC,
So AC square equals
equals, wait,
AD
BA, wait, AD
times AB.
times AB.
So the last one is AC square equals to AD times AB, correct?
Yeah.
Okay. So let's look at this three theorem again. This center one square is this two guys product. Now this center one is the left guy times the right guy. And this AC on the left, this guy square is AD times AB. On the right, this guy square is AB times BD. Okay, so this three theorem helps us solve many complicated questions for the right triangle. I'm going to have two more formulas. Look at here. As a right triangle, Debbie, what's the formula to calculate this triangle area?
Area? Wait.
ABC is 1/2 base times height. Who is the base?
AB.
AB times,
CD.
there you go, equals, in this right triangle, you can also draw this rectangle in this way. So this is your base, this is your height, correct? So you can also say 1/2
AC times CD.
AC times BC, correct?
Yes.
All right. And then we times 2. Correct. All right. Now, these are the 4 important formulas. I'm going to highlight, okay? Okay. Well, we always know that the Pythagorean theorem is still working, okay? Now let's go do the practice. Okay, I have to pause the video. My tummy feel hurt so much. I want everybody to work on this question on this page, and I will be right back, okay? I will compensate the time. Okay. I don't know how many questions you finished. Let me quickly check, okay? Look at number 1. They give you here to be 100. And they told you this is 36. And they ask you for this piece. I noticed that when I teach these formulas, students feel clear about it because the way they draw the triangle is this rotation. But for those practice, they don't always put the triangle in this way. Sometimes they rotate into different directions and people feel confused. So look at here. Abby, what do you want to do for this question?
X squared is equal to like one. Okay, I don't know how to like describe it, but just like 36 times 64.
Exactly. This guy square is 36 times 64. Exactly. Very good. What will we do next?
Take the square root.
Very good. Yeah, we don't want to times this to be a big number. We are going to do this square root. 36 square root is who?
6.
64.
8.
So this is 48. Makes sense?
Yes.
Very good. Next, Branson. Look at this triangle.
Not wait.
You have, look, I'm going to show this. Okay, so I show the formulas on the right, and then you can see which one you want to use. Okay, you suppose you rotate this triangle into these directions. Okay.
Okay.
Here, AC squared equals to AD times AB, correct?
Yeah.
So X squared equals?
9 times 16. Wait,
this guy square, AC square. AC square is AD times AB.
oh, 9 times 25.
There you go. So how do we remember this formula? This is a fast way to remember. This guy square is the left times right. That's easy. This piece square is, this guy is like the object itself. And this is a projection. So this guy, so suppose your light is coming from this direction. This is your shadow. So this piece square is a projection times the whole. Same way, this guy square is this piece times this whole. Okay, that's a fast way of remembering. So go ahead, finish this, please.
X squared equals 225.
We did the square root.
Oh wait, X equals 3 times 5 equals 15.
Okay, thank you. Debbie, let's do number 3.
Okay. Wait, give me a minute. Hold on. X squared equals 9 times 25. Oh wait, no. Wait, hold on. X squared is 9 times 16.
Thank you. X equals?
X equals 12.
3 times 4, right?
Mm-hmm.
Okay. Now, Abby, number 4.
X squared is equal to 16 times 84.
X squared equals,
Oh, sorry, I wasn't reading the right one.
oh,
X squared is equal to 18 times 45.
that's 81, right?
81 times 45.
Uh-huh. Yeah, this is, I think they mark this as 81, not as 18. Okay. 81 times 45. And then X will equals, we can did this first, okay?
9 times,
We can do this first.
okay.
And then 45 is who?
3 times square root of 5.
There you go.
27, yeah.
Okay, very good. Abby, no, Branson, number 5.
X squared equals wait, 7 times 9.
Mhm.
X equals 3 3
7 times 3, which
Oh,
is
yeah.
3. Okay. Now Debbie.
X squared equals 16 times 84.
Okay.
And that's 4 times
84 can be simplified to what?
21 and 4.
Yes.
So 8 to the square root of 21.
There you go. Thank you. Very good. Abby, number 7.
12 squared equals X times 16.
And then X equals,
12 squared divided by 16.
we do this and we can simplify, okay?
Okay.
This divided by 4.
3,
Okay.
4.
And again, correct.
Yes.
X equals,
9.
okay, very good. Next, Branson, number 8.
Wait. Oh, wait, 48 equals
38
wait.
squared.
Oh yeah, 48 squared equals X times 64.
Okay. Let's simplify.
X equals wait, 8. Wait, no.
Divided by 8.
Yeah.
Divided by 8. Correct.
Yeah.
Okay. And then this divided by 8 is
6.
so X equals
12. Wait. Oh.
36, right? Yes.
Oh, yeah.
Yeah. You might notice that this, yes, this
Yeah.
guy's square root is 8. This is 6. Correct.
Yeah.
That's why. Okay. Next. Debbie, number 9.
36 squared. Wait, no, hold on. Mm, Oh, wait, hold on. 60 squared equals 36 times x.
60 times 60 over 36. And then we can simplify. Go ahead.
5 and 3.
Actually, 6. This is just the 3600, correct? So this is
100.
there. You go. Make sense now?
Yes.
Now, Abby, number 10.
7 times square root of 33 squared.
Equals
Wait, x times 33.
yes. The left is
49 times 33.
yes. So x equal
49.
very good. Okay. Let's see. Person number 11.
X, wait, no, 14 times square root of 6 squared equals 24 times x.
Okay. On the left.
X equals wait, no.
Let's do this first. Okay.
Oh, okay.
Okay.
20 wait. X equals wait.
Okay.
Oh, yeah.
And then we can simplify. Go ahead.
24 is 12. Wait.
Okay. So you divide by you can divide by 6 first.
Oh, yeah. Equals 4. And 6 is 1.
Continue.
X equals 196 divided by 4.
This divided by 2 is 7. Okay.
Okay.
And then this divided by 2 is 7. This is 1. So this is 49. Make sense?
Yeah.
Okay. Now I keep enforcing students to work on this kind of mental math so that you can do well for the non-calculus sessions. Okay. Debbie, number 12.
6 13 squared equals x times 13.
Good.
And then you 6 squared times 13.
Okay. X equal
36.
there you go. Okay. Next one. Abby, look at the number 13.
60 squared equals 36 times 36 plus x.
Next, we can change the left to be
The left to 36,100 equals 36. Okay.
Okay, so
100 equals 36 plus x.
very good.
X
X
is
equals
equal to 64.
very good. This is nice. Person number 14.
uh, wait, wait, no, 48 equals, 48 squared equals uh, 64 minus x. Wait.
Hold on. This is 64. This is x. This piece is
X, wait. Oh, yeah.
okay. Correct.
Yeah.
Yes.
Yeah.
And now let's simplify. 48 squared can be read as 6 squared times 8 squared, right?
Yeah.
Okay. And then does this two cancel?
Yeah.
So
36 equals x minus 64. X equals 100.
Very good. Debbie, number 15.
15 squared equals 9 times x. Wait, no, 9 times x plus 9.
Okay. The left is,
225.
so we can do 3 squared times 5 squared, okay? Does this cancel?
Yes.
So 25 equals
Equals
9
9,
plus x equals,
16.
there you go. Next one, Abby, number 16, please.
6 times square root of 11 squared equals x times 11 plus x. Is it
This guy square is
11
that
times
one.
x plus 11?
Yes, thank you. Continue.
36 times 11 equals 11 times 11 plus x.
Okay,
36 is equal to 11 plus x. X is equal to 25.
there you go. Very good. Next one, number 17. Branson, go ahead, number 17.
Wait. Wait. 50. 50 times square root of 3 squared equals 75 times 75 plus x.
Okay.
uh,
We can do 50 times 50 times 3. Okay,
yeah.
make sense?
Yeah.
Okay. This is
150.
This is
75.
150 over 75 is how much?
2.
There you go. Correct.
Yeah.
So
X equals wait. Oh, x equals 15. Wait, no, 25.
okay. Okay. All right. Thank you. Debbie, number 18.
6 times square root of 85 squared equals 36 times x minus 36.
Okay.
6 squared minus 85 equals 36 times x minus 36.
Wait, hold on. Let me charge my computer. Okay. 36 will be canceled, correct?
85 equals x minus 36. X equals 121.
Very good. Okay. All right. So that's those questions here. Let me see. In this worksheet, so we are going to quickly review some of those perfect square or radicals simplification questions. Abby, let's see. 144 is who? Square root 144.
Plus or minus 12.
Hold on. This guy itself is positive. So this is just equals 12.
Okay.
If I write down negative, this is negative, okay? So it is positive 12, okay? Yeah, continue, Abby. 150, how do we simplify this now?
150 is
25 times who?
oh shoot, 25 times 6.
So
5 times square root of 6.
number 3, one more, please.
9 over 10.
That's good. Person, number 4.
Wait.
Who is 98?
Wait.
49 is 7 square. So this will be 7 square 2 over 5. Correct?
Oh, yeah.
Okay. Next one.
121 square root 121 is wait 11 over 5.
Very good. Number 6. 98. Mhm.
7 times square root of 2 over uh wait, 4 times square root of 2 equals 7 over 4.
Very good. Okay. So next we need to introduce the geometric mean. When you have two numbers, your geometric mean is saying you do your two number product and then you do the square root. Okay. This guy, if they ask the geometric mean, you will do 7 times 9 and then do the square root. This gives you 3 times square root 7. That makes sense. If you have two numbers are the same, your geometric mean is going to be square root of 14 times 14. So this is still 14. Okay. You don't take the negative, you just choose the positive. Okay. For number 3, they ask you geometric mean. So you're going to do their product. Their product equals to 2 times 3, which is 6. And then do the square root. That is square root 6. Okay. Now I'm going to ask Debbie to do the next 3 questions. Debbie, go ahead.
8 times 2.
Is 16. So the answer here is
4.
good. Number 5.
Oh, 9.
That's good. 6.
Uh, 3 over. Wait.
You did it correct. This is 3 over 4 times.
And 5 over 6.
Let's simplify. Correct. So that equals,
5 over 8.
there you go. Okay. For the other questions, it's similar as what we did for this practice, which are using everything we have learned, the important formulas. Okay. Look, given AD and CD, they ask you DB. This guy's square is this two product, so you can find the DB. For number 2, you know here, you know here. This guy's square is this two product, so you can also get this one. Number 3, you know this piece is 3, this piece is 6, and then you want to ask here. Well, you do this guy square equals to this small piece times the whole piece. So you need to 3 times 3 plus 6. Okay, so you can also get it. So that's another practice. Okay, you can do your own up to here. I do list my solutions in details. Okay, so finish this part. You can hold this page questions. You can do everything for the first page, and you can also do everything for this page. Okay, I'm going to upload the homework and the notes. And my daughter is a junior for Clement High. for junior students in Clemens, the stress level is extremely high. That's why we want to learn early. Yeah, by the time of your 11th grade, you can still sleep like 4 or 5 hours per day. Okay, yeah. Y'all 3 do very good. Keep up your good work. Go through the notes and make sure print out this blank worksheet and do it by your own. You don't need to finish every page. You can leave this page. If you want to do it, you can try. If you think it's hard, you can hold on there. We will still teach about this page next class, okay? And I also upload these notes. So make sure you are able to derive these formulas by yourself without looking at my notes to master all these formulas. These are extremely important formulas for geometry. You might have this kind of question in those PICT, okay? That's for today's class. I will upload the video and I see you next week, okay? Thank you, bye-bye.